हेलो एवरीवन, वेलकम टू द प्लेटफॉर्म ऑफ अनअकैडमी, इंडियाज लार्जेस्ट ऑनलाइन लर्निंग प्लेटफॉर्म। आप लोग सभी का स्वागत है अनअकैडमी के प्लेटफॉर्म पर। सो लेट मी जस्ट चेक द थिंग्स। ओके, सो I welcome you all to this amazing platform, which is Unacademy, which is India's largest online learning platform, where we are actually studying casting. Okay, so this is a brief introduction about myself, sir. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as R&D experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research. I have qualified GATE twice. I'm the author of several research papers, which is actually research papers of national and international journal of repute. You can follow me at the Unacademy app. So this is the fourth part of casting, which we are actually seeing. We have completed the metal cutting. Now we are in the fourth part of the module 2, that is the casting. Hello Indrajit. Good evening Ashish ji. Good evening. Good evening. Good evening to everyone. Good evening. So now you can download the Unacademy Learning app because it has a lot of benefits. Because Unacademy Learning app has a free lessons. Okay, so you can watch a lot of free lessons, and currently I am teaching a strength of material at a special class. So you can join my special class of strength of material there, as well as for a paid classes are also there. And in the paid classes, that means that plus subscription you have to take. So firstly take that firstly try to try to get accustomed with that educator in the YouTube. Then if you think that okay, that this educator is good, I'm having a good tuning with him and he can make me understand everything, go and take the classes that is a free lessons of them. And if that time also you feel that okay, everything is okay, you should feel free to go for a plus subscription, because that is really worth it. So it has a benefit of daily life classes are the structured courses are there, because in YouTube there might be conditions that you may not find one or two lectures that are in my chronological order. But in an academy learning app you will get everything with structured courses. Unlimited access of the resource materials are there, as well as you can practice live tests and quizzes. So now there is a benefit. You can always go for a plus subscription, because I have told you there would be 100% coverage of syllabus would be there. 100% coverage of syllabus would be there, and a lot of top educators are there at the plus subscription. You and I have told you, just take the classes of just attend the classes of the educator firstly in the YouTube. And if you feel that okay, this educator is good, I can have a good tuning with him, he can make me understand every concepts, he can simplify everything, go and take the free classes. Go and download the Academy learning app, take the free classes, and once you think that everything is okay, go for the plus subscription. And see, there are the planning for a plus subscription. For a 1 month it would be 5,000, for a 3 month it would be 12,500, for a 6 months it is 20,000, and for a 12 months it is 25,000. So if it is a 25,000, you can always use my code SIRVK, and you will get a 10% off when you will use my code SIRVK. So always remember SIRVK, SIRVK. My code is SIRVK. When you will use my code SIRVK, you will get a 10% off, as well as I'll provide my mentorship and help you throughout your preparation of GATE and ESE. Apart from that, For a 24 months plan, it is 30,000, and if you will use my code SIRVK, 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 then you will be getting a discounted amount would be 27,000. So this is what is the thing. Good evening, Subradeep ji. Good evening. Hello, Priyank ji. What is problem? Pratik ji, can you tell me it is loading? Hmm? Let me check it. My audio, video, everything is okay? So you can always go for a plus subscription if you think, and see, an academy has a lot of top educators. Once you get the feel of the once you get enrolled in the plus subscription, you can attend all the classes of the all the educator that are in plus platform, as well as the Unacademy has a lot of batches for the mechanical electrical courses for the EC, CS, IT, civil, and so on and so forth. So everything you have in this platform. And the benefit of this plus subscription is that one subscription and benefit of two, right? So there is a two in one benefit. GATE and ESE, you can prepare both of them. Okay, so Pratik is telling now it's okay. Okay, fine, fine, fine. Okay, so what is Deepak ji? No, 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 you are not too late. You are on time. You are on time. Everybody, you all are on time. So till now, what we have been discussing, this is the fourth part of the casting that we have been discussed till now. And now this in this session, we will be discussing some of the important topics from the numerical point of view, which are asked in GATE. Okay, so let us see the first topic, that is of core. Okay, so earlier actually I have introduced about the types, like how many types of gates are there. But before going into the gates, I will just finish a small topic, little bit, very small topic is there of the core, and from that core actually a lot of questions are asked in gate. So let us cover that small topic, and after covering that topic we will rush into the topic of gate. Okay, so core. So see, we have already seen what is a core, what is the use of a core. So core is actually, it is used for making cavities. Okay, we know that whenever there is a requirement to make a cavity, we will use core. Okay, and cavities and hollow projections. So whenever the hollow projections are required, we will we will use the core, right? And these the reason why we are using the core, because we cannot, there is no alternative of core, right? If I want to make a cavity or a hollow projection itself with the pattern, it is not possible, sir. I cannot make a cavity or a hollow projection with only use of the pattern. That's why core comes into the picture. So it is used for making cavities and hollow projections which cannot be normally provided by pattern. Clear? So this is what is the use of a core. Okay, this is what is the use of a core. Now suppose I'm drawing some figures. Suppose this is my mold cavity, right? So this is my mold cavity. Suppose this is my mold cavity, clear? And in this mold cavity, I want to make a hollow cavity, clear? I want to make a hollow cavity. So what I will do, I will just make a hollow cavity. Suppose I am putting, so this is my mold cavity. This is my mold cavity. In this mold cavity, what I am doing, I am just putting the core. Okay, I'm just putting the core. So here I have put the core. Clear? Here I have put the core. Yes, it is good. Deepak ji, yes, it is good. You can practice a lot of, see, even if you will prepare previous year paper, that is going to help you. Eventually, that is going to help you. Okay. So see, so this is my mold cavity. Clear? So this is my mold cavity. So this is my mold cavity. And now, so, and this is, what is this? This is my core. This is my core. And you know that core is made up of baked sand. Okay. I have already explained you that how core is made of the baked sand in the earlier sessions. Now see, this is my mold cavity is there, and this is my core. And see, to support the core, there is a requirement of chaplet. Okay, so there is a chaplet. Suppose this is a chaplet. Okay, so suppose this is one chaplet, this is another chaplet, this is another chaplet. Okay, so why we are using the chaplet? Because core is very fragile in nature. Core is very fragile in nature, and to support this core we need some extra thing that can support this core. This weight can its weight can be supported, and hence suppose we are using, here we are using the chaplet. Clear? Here we are using the chaplet. These are the chaplets. Suppose these are the chaplets. Clear? Now, so these are the chaplets. So these are the chaplets. Now see, now see. So this is the core. This is the core. Clear? So this is the core. No, see, chaplets are made of the metal, of the same metal which we are pouring into the cavity. In the Indijit, see, suppose if I am pouring the cast iron, if I am pouring the cast iron, then I will use the chaplets of cast iron. Clear? So that, so that when we are pouring the molten metal, that molten metal is so much hot that it will take the shape. So everything will be there, right? Got it? So this is my core. So this is my core. And in this core, so this core is made of the sand. I have told you. In this core, what I will do, I will pour, I will, I will pour the molten metal. Okay. So in this, here I am pouring the molten metal. Suppose this is my molten metal. Clear? So throughout the mold cavity, molten metal is there. Throughout the mold cavity, molten metal is there. Clear? Throughout the mold cavity, molten metal is there. Now see, now see what will happen. Suppose this core has, suppose there is a rho L, that is density of the molten metal. Okay, so let us assume the density of molten metal, that is the molten metal flowing here, is rho L. Clear? Now again, let us consider the density of the core, right? And core is made up of the baked sand. I have already told you. So density of core, let us assume it to be a rho. Clear? Now see, I have defined the density of both the things. I have defined both the densities, and let me tell you one thing very clear, that from here, density of liquid, that is the molten metal has some density, and this density is always greater than the density of core, so this is the important condition, that is the density of the core. So this condition is given to you. Now see, now see this condition. What is happening, that throughout this thing, this, let us consider this to be a body, core to be a body. This body is completely submerged. This body is completely submerged, right? So let us assume core to be a body, and this body is completely submerged in this. And see, I'm actually, the molten metal is passed through it. So this core, that is this body, is completely submerged in the molten metal. Clear or not? So we can see that this core is completely submerged, and it can be, this case can be identified as a fluid case where a body is fully submerged. So let us analyze this case once again, so that we can get some results. So see, so what I can consider, suppose this is my core. Suppose this is my core. So this is my core, and this core is made up of sand. Clear? So the core is made up of the sand. Baked sand is there. So this is clear to you. And in this core, uh, can we start the class from 9 p.m.? 9 p.m. I have also some problems, Subham, but what I can do, I can change it to 8 also, but not 9. That would be too much late. So see here, so this is a core. This is a core, okay, and in this core is fully submerged. Okay, this core is fully submerged in the molten metal. Clear? So that's what we have seen now. Just now, that's what we have seen. See here. These all are the Deepak ji. Let us focus it here. And when I will tell you to ask the doubt, then please ask me the doubt, and I will take everything. Okay. So for a time being, I'm not seeing the chat because these things take break the concentration. Okay. So मैं अभी चैट नहीं देखूंगा, ठीक है? मैं मोबाइल को साइड रख दे रहा हूँ, एंड आई एम कंटिन्यूइंग विद द टॉपिक. ओके, और थोड़ी देर बाद मैं आप लोगों का डाउट लूंगा. ओके, so see here, the just now what we have seen is this. Just now we have seen is this. So this is a core, and this core is fully submerged in this molten metal. So here, this is the core, and this is the fully submerged. So this is the core. Let me just write it here. So this is my core. This is my core. Clear? And this is my molten metal. This is my molten metal. Now see, this core is a case of a fully submerged body. So for a fully submerged body, this is a case of fluid mechanics, है ना? Sir, what we can do, we can assume the problem of core and molten metal to be a case of a fluid mechanics. Real? So see, this is, if this is a case of a fluid mechanics, what we can do, we can see that core is fully submerged, and for this condition we know that displaced volume, whatever the volume has been displaced by the core is actually is equal to volume of core. And let us assume the, what would be the volume of core? Suppose this is my, the this is the diameter, that is diameter is D, and let us assume the length to be L. Clear? So what would be the volume of core? Volume of core would be pi by 4 d square into L. And let us assume this displaced volume and volume of core to be V. Clear? V. So this is the result that we have got. Now see, now see that, so this body has its own weight, right? This body has its own weight, and just now here we have seen that, let us assume rho L to be the density of molten metal and rho to be a density of core. And since rho L is greater than rho, see here, since rho L is greater than rho, so you will have the weight of the core will act in the downward direction. Clear? Weight of the core will act in the downward direction, and since this core is submerged, fully submerged here, so there would be a buoyant force that would be acting. So this is the weight of the core, weight of the core, and here this is the buoyant force, and here it is a buoyant force. Clear? So we can now analyze this thing that here a wet force will act, a wet force will act, and here a buoyant force, that is, suppose FB. I think these things are making you problem, so let me change the color. So this is FB, buoyant force is FB, and this is the weight. Clear? So see, sir, what we have understood, that since density of molten metal is greater than density of liquid, density of coarse sand, hence we will get a weight in this direction and a buoyant force in this direction. Okay, so this is the center point, so this is the buoyant force, right? Now see, since the density of molten metal is greater than the density of sand, so we can say force will be greater, right? So buoyant force will be greater. If buoyant force will be greater, then there would be a net, there would be a net upward force would be there, right? So there would be a net upward force. So there would be a net upward force, or it is known as net buoyant force. Clear? So this is what is the scenario that when we analyze this core and the molten metal condition. Now see, what is the net? So let us consider this to be a F net. Okay, F net. Now what would be the net force? What would be the net force? F net would be what? So F net will be FB, that is the buoyant force minus the weight of the core, right? So see, from this thing we can very easily say, from here we can easily say, so net force is going to be is equal to buoyant force minus the weight. Now see, what is the buoyant force? What is the buoyant force? Buoyant force is actually rho into G into H. Clear? That these things we know, that rho into G into volume, right? Rho G into volume. So these things is clear to us. So I can write that rho L, that is the density of the molten metal, into G into V. V is the volume. V is the displaced volume. So this is the V minus rho. What is W? Weight. Weight would be, I have considered this to be rho. So let me consider here, rho is the density of sand or core, density of core, which is actually made of sand, and rho L is the density of molten metal. So rho into G into V. Now if I will rearrange these things, what I will get as net buoyant force is nothing but rho L minus of rho into GV. And see, And see what we have seen, that at this point weight is acting in downward direction and buoyant force is acting on upward direction. So there would be a there would be a net force, there would be a net force which is acting in upward direction. So we can say that this is the net amount of force that is acting in this case, and its direction is going to be upward. Clear or not? So till now everything is clear to you, the concept of what I have told you. So this formula is very much important from gate point of view. This formula is very much important from gate point of view. Okay. uh, Sir, what is the dendrites and how they are formed near the wall? See Deepak, these things are ये सब जो होता है ना, ये सब सारा प्रॉब्लम होता है आपका इम्प्योरिटीज के कारण, ठीक है? वट एवर द इम्प्योरिटीज आर देयर इन while pouring the molten metal. So when we are pouring the molten metal, there are a lot of impurities in that molten metal. So due to them, the dendrites are formed near the wall. Okay, clear? So till now, if you have any doubt, tell me, everyone. Tell me if you have any type of doubt, then ask with me. So this is the very most important, I would say, that not most important, but from this question, from this actual topic, a lot of questions are asked in gate. Okay, and you can expect a good questions from here. So okay, so you all have don't no doubt till now. So assuming that you don't have any doubt, let us move to the next thing. Now try to solve this question. Try to solve this question and tell me the answer. Try to solve this question and tell me the answer. I'm giving you a 2 minutes time. Try to solve it. If you are having facing any problem, then I'll explain these questions in details. Try to solve this question and tell me the answer very fast. Very fast. Any answer? Try it and tell me the answer. A. Okay. What about everyone? Okay, see here, I'm explaining this question. See here, I'm explaining this question. So just now I have told you the concept, just now I have introduced you the concept. So there is in sand casting of hollow part of lead, a cylindrical core of diameter 120 mm, height 180 mm is placed inside the mold cavity. So there is a mold cavity, and in this mold cavity a core is placed. Okay, so a core is placed. Clear? And in this mold cavity the core is placed, which is having a diameter of 120. So this is the diameter. Clear? So diameter is given as 120 mm, and height is given. Okay, so suppose, so what does it means that core is placed like this? The core is placed like this. Okay, the core is placed like this. The diameter is given, that is d. Height is given, height is given. Suppose this is h. So height is given as 180 mm. Now it is placed inside a mold cavity. So this is your core. Densities of core metal and lead are given as this much. Okay, so core metal is what? So density of core metal is given as 1600 kg per meter cube, and density of molten metal, that is the lead, is given as, so let us assume to be a rho L, it is 11300 kg per meter cube. So these things are known to us. This is the lead. So throughout the molten metal there is molten metal is filled up here, and this molten metal is of lead. Clear? Now we are required to find the net force that tends to lift the core. So what would be net force? Net force would is going to be is equal to rho L minus of rho into G into V. Just now we have seen this. Just now we have seen this, that how we can find the net force, rho L minus of rho into G into. So just now, just you apply these things. What is rho L? Rho L is 11300 minus of 1600 into 9.81 is the value of G into volume. Volume would be pi by 4 d square. So d square, let us assume d square 120 square into 180. Now see, 120 is in mm. Okay, so to convert this into the meter, so what I can do, I can multiply with 10 to the power minus 3. Okay, so 120 10 to the power minus of 3. Okay, and this will also be converted 120 10 to the power minus of 3. This will be meter, this will be meter. So see, this is a d square. So 10 to the power minus 3, 10 to the power minus 6, 10 to the power minus 6, and 180 is going to be, so this thing will be 10 to the power minus of 9. And when you will calculate this, you will be getting as 193.7 Newton. Clear? So our option is going to be is equal to C. Clear? So this question is clear to you, and these questions are previous year GATE. Okay, these questions are of actually previous year GATE. Previous year GATE questions are there. Now try to solve this question. Now try to solve this question. Now just attempt this question. And if you have any doubt, meanwhile, if you have any doubt, then ask with me. So Indrajit has given correct answer for that. Shiv given, Ashish given. Okay, and Pratik also has given. Okay, good. So if you have any doubt till now, then you can ask with me, and also you can solve this question and tell me the answer. Try to solve this question and tell me the answer. Same thing is there, but Believe me, the concept is same, everything is same, but these type of questions are asked in GATE. Okay, try to solve this question. See here, there is a aluminum alloy. There is a aluminum alloy which is having a density of 2600 kg per meter cube. Fine. So yes, the option is A. Option A is correct. Ashish and Mukta. Option A is correct. See here, so there is aluminum alloy which is made up of alloy is made up of aluminum. So that is actually having a density of 2600 kg per meter cube, and casting is to be produced. Clear? A cylindrical hole of 100 mm diameter and 100 mm length is to be made in a casting with a sand core, and density of sand core is given as 1600. Density of molten metal is given as 2600. So this, in this question, it has been asked to find net buoyancy force. Net buoyancy force. So how you can find the net buoyancy force? See, net buoyancy force, I have told you that formula of net buoyancy force is density of molten metal minus density of sand into G into V. Now, what is the density of the density of molten metal is this? So this is the density of molten metal. Now this is the density of sand, right? Better to say core sand. So density of core is there. This is the density of core. This is the diameter. This is the diameter. This is the height. So I can just replace these things. So density is given as 2600 minus, again density is given as 1600 kg per meter cube. And what is the G? G is given as, you can consider G. So G is going to be 9.81 meter per second square into, what is the volume? Volume is going to be is equal to pi by 4, 100 square into, again there is a 100 into 10 to the power minus of 9 meter cube. Clear? So from here, what you will get the net force? Net force, if you will calculate, you will get the net force as 7.7 Newton. Okay. So Ashish, Mukta, Indrajit, Prateek, Shiv, great. Everybody has given the correct answer. Okay. So good, 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 good. So now, till now, this was the very small topic of core was there, and so that's why I wanted to complete this topic of core, and then I wanted to move to the next topic, that once that actually I have started in yesterday's class, right? So for a gate, so let us see here. So till now, if you have any doubt, tell me or give me a thumbs up, so that I can understand that you have no doubt and I can proceed. Okay. See, see here, that when, so this is, these things are clear to you, I think. Okay, so this is a pouring cup, right? So this is a pouring cup. Let me write it here. This is a pouring cup. This is pouring cup or pouring basin we have seen. See, this is the sprue. So this is the sprue. This is the sprue, right? This is the runner. This is the runner, right? And this is the ingate. Clear? And this is, suppose this is my casting. Okay, this is my casting. So now, so now what is the thing? At the top of a sprue, at the top of a sprue, there is a metal. At the top of a sprue, there is a metal. Okay, there is a metal at the top of a sprue. So at the top of a sprue, what I put, a metal. So a metal plate. Metal plate is on the top of a sprue. Clear? And on this, somewhere in between, there is a thing that is also put. That's name is strainer. Strainer. Okay. And at somewhat here between runner and in this, on the runner, there is a typical shape structure is there, right? So somewhat like this. Its name is scheme bob, not SpongeBob. Its name is scheme bob. Okay. Now see, let us understand this scenario very very seriously. Okay, बहुत seriously सर समझना है scenario को. Now see, you are pouring some molten metal. You are pouring some molten metal, right? So you are pouring the molten metal here. So you have poured the molten metal, right? So here is the molten metal. So here is the molten metal. Clear? So this is the pouring basin, and in this pouring basin, molten metal is there, and this molten metal will flow from here. Clear? Now see. Now see here. With this molten metal will include some impurities. Okay, so there would be some impurities associated with that metal would be there, and this impurities will also flow through this impurities will also flow through this, and hence these impurities are going to go into the casting. Clear? So ultimately, if the impurities are here, so these impurities are going to be in my casting, and if my impurities will be in the casting, then my casting quality will be very bad. So see here, to counter this problem, to remove the problem of impurity, first thing is there, we put a metal plate first, right? So why we are putting a metal plate? So when you are pouring the molten metal, so this molten metal will be having some velocities, right? When you are pouring the molten metal, this molten metal will have some velocity. Now this pouring metal get in the shape of the pouring basin, so here it will settle down, and hence its velocity will subside. Now if you will put a metal plate here at this position, if you will put the metal plate here, then at due to the presence of metal plate, whatever the velocity is, still now suppose if have the velocity of like 5 meter per second is there. Now when it has been reached to the pouring basin, suppose it has a 1 meter per second. So now at this metal plate, all the velocities is going to subside. All the velocity is going to be subside because of this obstruction. Because of this obstruction. So hence, hence, what is happening at this point? Velocities are going to be very constant, or constant velocity is there, right? Or a constant velocities are there. So if a constant velocities would be there, then the flow would be laminar, throughout the sprue. Now see, at random अगर मैं पुट कर दूं तो turbulent flow हो जाएगा, ठीक है? Turbulent flow हो जाएगा. If turbulent flow would be there, so my sand casting, my sand molding would be there, right? So sand molding will get disturbed. My sand molding will get disturbed. It will get eroded. Everything will be ruined. So this is the use of a metal plate. So I think the use of a metal plate is clear. Next thing is what? There is a strainer. So this molten metal, flows through this. Clear? So this molten metal flows through this, and it comes to this part. So molten metal flows through it and comes till the strainer is put. Okay, so it is moving through the sprue, and once it came to the strainer part, so we have seen that this molten metal have some impurities. This molten metal has some impurities. So here is the impurities. Here is the impurity. Clear? And what is the use of a strainer? So actually strainer is made of a porous ceramic, porous ceramic material, and its function is to restrict the entry of impurities. Okay, to restrict the, so let me write at is impurities, to restrict the impurities. So at this point where all the almost like many of the impurities will get restricted. So now what will happen at this point, after this point, my molten metal will flow. Okay, my molten metal will flow through this. So it is flowing. Now see, at this point, at this point at this point there was a lot of impurities, there was a lot of impurities, there was a lot of impurities. And at this point there is some little bit impurities are still with this molten metal. सारा का सारा impurities स्ट्रेनर नहीं निकाल पाता, कुछ बहुत फाइन पार्टिकल्स भी होते हैं impurities के जो वहां से निकल के चले आते हैं. Now what is the function of this scheme bob? Scheme bob क्या करता है sir? Scheme bob actually takes these impurities. Okay, so impurities in the upper part is taken by upper part of scheme bob, and impurities in this lower part is taken by the lower part of the scheme bob, and hence scheme bob and strainer both helps to remove the impurities. Scheme bob and strainer both helps to remove the impurities. And see, after that we are getting a very fine molten metal with no impurities or minimal impurities are there, and hence we are getting a very good quality of casting. Clear? Hence we are getting a very good quality of casting. So I think this whole process of pouring metal and how the impurities are removed, these things are clear to you. Okay, now see, we are going to, so there is some heavy impurities are there, we can say that very heavy impurities at this section. Clear? At, so when it was passing through a sprue, so with the help of a strainer, so there was a strainer, so with the help of a strainer my impurities has been removed, as well as with the help of a scheme bob my impurities has been removed. Now consider, so this is my bottom, so this is my bottom area, right? So this is my bottom area of the sprue, right? This is my bottom area of a sprue. So let us consider AS. What is AS? AS is the bottom area or bottom sprue area. Clear? So area at this part of the sprue, that is bottom sprue area. Next is what? So this is my runner, this is my runner, and the area of runner is going to be is equal to, let us assume that AR is my runner area. AR is the runner area. Next is what? So this is my in-gate. So let us assume that AG to be a in-gate area. So these are my things. Now there is a term which is called as gating area, or gating ratio is there. So we will see these things in details about the gating area and gating ratios. Now first of all, let us analyze the condition of a sprue. Let us see something more details about a sprue. So see, what we can see that is, what is the use of a sprue? Sprue is used to feed the molten metal, right? So from here we can see that molten metal is fed, right? See here, molten metal is fed, right? So from here we can see that molten metal is being fed like this, right? So the first function is proof. First function of this proof is that it is used to feed the molten metal from pouring basin to ingate. Right, that's what we have seen now, that from the pouring basin molten metal is fed till the ingate. So this is the first function. Now see, second function is that it should be able to prevent the absorption of air or gases from surrounding on the molten metal while flowing throughout. Right, now see, yesterday itself we have seen that if the from the surrounding molten metal will flow throughout, so that is a case of a what, that is the case of a aspiration effect. Right, so that is a aspiration effect. Okay, so it is very much important that it can prevent the absorption of these things, right? And hence if it can prevent, then aspiration effect will not be there. Clear? So aspiration effect will not be there. Now see, next what is the next function is that shape of a sprue is, right, we have discussed in yesterday's class what is the shape of this sprue. So see here again I am telling you. So the nature of molten metal will be flowing like this, right? Molten metal will flow like this. So in this way, the molten metal are flowing here, right? In this way, molten metal are flowing here. Now see, ideally it should be made a parabolic, right? It should be made parabolic, but it is made as a taper, right? So third point is that the shape, the shape of a sprue to avoid aspiration effect, right? To avoid aspiration effect, must be parabolic, right? These things we have seen that if there would be how the air is going like this, right? So from here air are going, right? So if the air will get here, then if air will get here, then the problem of gas defect will be there, right? So these things we have seen in previous classes, right? In previous classes we have seen these things in very detail. So it should be parabolic. The shape of the sprue should be parabolic, but must be in a parabolic shape, but due to manufacturing problem, it is normally a tapered sprue. Clear? Tapered. So till now, if you have any doubt, then ask me. Can sprue base remove impurities? See how we can improve, how we can remove the impurities, remove the impurities. Just now, Subhankar ji, just now that's we have seen that how we can remove the impurities. So to remove the impurities, a strainer scheme bob is there. Sir, इस कोर्स में कितने क्लास लगेंगे? As many as class is required to complete the course in a very proper manner, so that you will be able to attempt all the questions of GATE and ESE. And जब तक मैं करूंगा तब तक मैं करूंगा सर, जब तक मुझे यहाँ ना लगे कि आपका प्रिपरेशन जो है, मैंने आपको बहुत अच्छा कंटेंट दे दिया, नाउ योर प्रिपरेशन इज गुड, तब मैं बंद कर दूंगा, ठीक है, देन कास्टिंग विल बी ओवर। आई थिंक लाइक 5 classes will be more. I don't know actually. Okay. Point two, can you explain of sprue function? Point two, what is point two? It should be able to prevent the absorption of air and gases from surrounding. See here, Subham, see here, what is the meaning of there? Yesterday, in yesterday class itself, I have told you the meaning. See, it should be able to prevent the absorption of air or gases. See, this is my molten metal. This is my molten metal. This is the molten metal, right? This is throughout, this is my molten metal. When I'm pouring the molten metal, what will happen? So when you will open the tap, suppose a case of a tap, जब आप पानी खोलते हो, नल से पानी खोलते हो, तो you can see that the water is flowing in the parabolic shape. So here you can see that, you can see that, you can see that, so there is a gap, right? There is a gap here, there is a gap here. So air particles or the gaseous particles, what will they do? They will move to this, they will move to this. Now see, it should be able to prevent the absorption of this. Now what is the function? That these air or the gaseous particles should not be absorbed here, because if it will absorbed here, then it will mix with the molten metal, and if it will mix with the molten metal, then a problem of gas defect will arise, then the problem of gas defect will arise. Because see, suppose if I have this final casting, and in this final casting what will happen? There would be air entrapped in that, so air will try to move outside, air will try to move outside, and hence the holes will be formed on the outer texture of the casting, and these holes may be known gas defects. Are these are basically known as gas defects. And what are the gas defects? Like pinhole porosity, pinhole porosity is there. We are going to discuss these things in latter stages. Pinhole porosities are there, blow holes are there, big size are there, so blow holes are there. So these are things we will see. Okay, so this is the meaning. Okay, so this is actually we have seen yesterday, this is known as aspiration effect, है ना? इसको हम एस्पिरेशन इफेक्ट बोलते हैं। तो एस्पिरेशन इफेक्ट ना हो, इसको प्रिवेंट अगर करे, दैट इज द फंक्शन ऑफ स्प्रू। क्लियर? क्लियर? एवरीबॉडी क्लियर? टेल मी, एवरीबॉडी क्लियर? Now I think this is clear to you. Okay, so I'm moving to the next topic. So I'm moving to the next topic, that is the runner. Let us see the runner. See, what is runner? What is runner? So see, it is a connecting passage. It is a connecting passage between the bottom of the sprue. See, this is the bottom of the sprue. This is the bottom of the sprue. This is the bottom of the sprue, and this is the ingate. Okay, so this is the ingate. So runner is a connecting passage between the bottom of the sprue and the ingate, right? So let me write it here about the runner. So what is runner? So runner is a connecting passage between the what? See here, between the bottom of the sprue, right? Bottom of the sprue and ingate. So between the bottom of sprue and ingate. Clear? Now see why this runner is given. So this, the help of the main function of this runner is to avoid the sand erosion. Avoid the sand erosion. Now see here, See here, what is the uh, if we will write the from the fluid mechanics point of view, see from the fluid mechanics point of view, because why we are relating this scenario with fluid mechanics, because see here, earlier also I have analyzed this situation with the condition of a fluid mechanics, and then we have derived this beautiful formula of gate, which is really asked in gate, that is a net buoyant force. So we have actually analyzed these things with the taking the consideration of a fluid mechanics. So the reason behind is that molten metal is actually a fluid. Molten metal is actually a fluid. So if we will write the equation of a fluid mechanics, head equation of fluid mechanics, that is in there, that is 32 mu u bar L by rho g d square, right? So if you could remember, this is the head formula, this is the head formula, and if this head formula, from this head formula we can say that this head is actually proportional to velocity. This head is actually proportional to velocity. Clear? This head is actually proportional to velocity. Clear? Now see, if velocity will be more, if velocity will be more, then erosion will be more, right? If velocity will be more, the erosion will be more. But here, see in this case, see here in this case, so earlier it was here, now the molten metal will gain some velocity, molten metal will gain some velocity, and see, so at this point again, when it is reaching to the runner, its velocity is going to be subside, right? So its velocity will decrease here. So here, see, its velocity is going to decrease, then velocity will increase, erosion will increase, velocity will decrease, erosion will decrease. And see, here is the sand particle, sand mold cavity is there here. So we do not want my mold cavity to get eroded, right? We do not want our mold cavity to get eroded, and hence we use a runner. And its help is, the use of the runner is that it avoids the sand erosion. Clear? So why it is avoiding the sand erosion, this thing is clear to you? This thing is clear to you? Now see, one of the most important thing that I want to tell you is that, see here, a condition. Suppose this is my mold. Suppose this is the mold cavity. Clear? So this is the mold cavity. Suppose this is the mold cavity, and we have seen what we have seen. See, there is a gate, right? So this gate, this is known as gate. This part is known as gate. Clear? So there is a gate which is so this gate is actually helpful in flowing the molten metal into the mold cavity, and hence the casting is formed. So see here, so there is a gate, right? So there is a gate. So there is one sprue here, right? So from a single sprue, you are you are feeding into this mold cavity. Okay, this is a mold cavity. This is a mold cavity. Now see, this is a sprue, and from this sprue, the mold into the mold cavity, molten metal is flowing. Now, how much time it will take? If my mold cavity is very large, very large. See, if I want to make if my mold cavity is this much amount, like the amount of the mouse, right? See the volume is very less. So there is no problem. We can use a single gate and a single sprue, and hence our problem will be solved. But what about that if you want to cast a road roller, right? Have you seen the road roller? What about if you want to cast like machine bed of the lathe, bed of the drilling machine, if you want to like that, right? Then what will happen? What will be the scenario? This single gate will not be enough to fulfill the mold cavity. Why? Suppose a condition that the molten metal is flowing from here, right? So suppose the molten metal is flowing here, molten metal is flowing here. At this part, molten metal is not there, right? So it will take time to the molten metal to reach to this part. Now the time taken by this molten metal to reach this part, at the meanwhile what will happen? Meanwhile, in these part, molten metal will solidify. क्लियर? सो जब तक सर उस दूसरे छोर पर पहुंचेगा, लेट मी टेक द लेजर पॉइंट, लाइक जब तक वो दूसरे छोर पर पहुंचेगा मोल्टन मेटल, तो उससे पहले ही सर इस छोर पे मेरा जो मोल्टन मेटल है वो सॉलिडिफाई कर जाएगा, है ना, पहले ही सॉलिडिफाई कर जाएगा। तो मैंने फिर से बताया है कि सर जब हमारा मोल्ड कैविटी बहुत बड़ा होगा उस केस में, मोल्ड कैविटी बहुत बड़ा होगा उस केस में, जब हमारा एक ही इनगेट और एक ही स्प्रू वाला कंडीशन होगा, तो क्या होगा, इस जगह पर मोल्टन मेटल आ गया, इस जगह पर आने में टाइम लगा, जब तक वो इस जगह पर आया तब तक इस जगह पे सॉलिडिफिकेशन हो गया। सो हियर देयर इज अ ह्यूज प्रॉब्लम, एंड दिस प्रॉब्लम इज नोन एज, there is a problem of directional solidification। डायरेक्शनल सॉलिडिफिकेशन नहीं हो रहा है सर, ठीक है सर, डायरेक्शनल सॉलिडिफिकेशन नहीं हो रहा है। तो कैसे हम इस प्रॉब्लम को हटा सकते हैं? हाउ वी कैन रिमूव दिस प्रॉब्लम? बिकॉज इवेंचुअली एक जगह पे सॉलिडिफाई कर रहा है, दूसरी जगह पे नहीं सॉलिडिफाई कर रहा है, माय कास्टिंग विल बी वेरी बैड, आई विल बी हैविंग अ डिफेक्टिव पीस ऑफ कास्टिंग, दैट इज नन ऑफ यूज, दैट इज नन ऑफ यूज फॉर इन इंडस्ट्री। So to counter this, what I can do, I can use the same sprue. I can use the same sprue, and with the same sprue, I can make another gate. Clear? Suppose this is another gate, right? So I can use this, and I can make, suppose I can make like another gate, right? Another gate. So suppose this is a gate number 1, gate number 2, and gate number 3. Now if this is the case, what will happen? What will happen? From all the sides, molten metal will enter, molten metal will enter, and when the molten metal will enter from all the sides, then there is a chance of directional solidification, then molten metal will solidify uniformly. So there is a case of uniform directional solidification. So we must think about that. So we can say that multiple gates from a single sprue, right? See, this is a sprue, and sprue is single, and gates are 3. So what I can write here is that if the runner feeds more number of gates, the runner dia is reduced. See here in this figure, this is my head. This is my net height, right, at here. So let us assume this net height to be ht, this height to be ht. So see here, in this case what I can say that इस जगह पर एक रनर, एक गेट से आप फ्लो करवा रहे हो, ठीक है, एक गेट से आप फ्लो करवा रहे हो मोल्टन मेटल, आप इस गेट से भी मोल्टन मेटल को फ्लो करवा रहे हो, आप इस गेट से भी मोल्टन मेटल को फ्लो करवा रहे हो, तो क्या होगा सर, Q is equal to A into V, right? Flow rate, mass flow rate is equal to area into velocity. Now see, अगर मैं सेम मास फ्लो रेट से तीनों जगह से मोल्टन मेटल को फ्लो करवाता हूं, तो क्या होगा, तो प्रॉब्लम क्या होगा, फिर से वही प्रॉब्लम होगा कि यहां से मान लीजिए कि अगर यहां पर ज्यादा जगह है तो यहां से पहले मोल्टन मेटल आ गया, यहां से, क्योंकि देखिए टाइम टेकन time taken by the molten metal from the path 2, from the gate 2 is more compared to time taken by the gate 1. and compared to the time taken by gate 3, and if flow rate is going to be same, then there is a problem, then this directional solidification will not be there, because कहीं से कुछ आएगा, कहीं से कुछ आएगा, लेट से आएगा, और फिर directional solidification नहीं होगा. तो हम क्या कर सकते हैं? Then what we can do, we can actually either increase the area and increase the volume so that my mass flow rate will increase, and hence there would be a directional solidification. Now how can I increase the mass flow rate? Either I can increase the area or I can increase the velocity. Now see, what is the velocity? What is the velocity? See here, from here what we can say that from since the molten metal is poured from here, so this is my height ht. So we have seen in the yesterday's class that velocity is going to be is equal to root under 2g into ht. So see, this ht height is fixed, head is fixed. So since head is fixed, so velocity is going to be fixed, so we cannot do anything with the velocity, right? So since we cannot do anything with this velocity, so what we can do, we have to change this area, and hence if the runner feeds more number of gates, the runner dia is reduced. The runner dia is reduced in area so that unequal discharge takes place at each gate. Okay, and अगर अगर यहाँ पे कम हो रहा है तो यहाँ पे उससे और भी कम होना चाहिए, ठीक है? तो no problem is there. So based upon that, I am going to decrease the area of here. Suppose I am going to decrease the area here, so my automatically my mass flow rate will decrease, right? So in this way we can manage that unequal discharge is flowing in through all the gates, and hence through this we can achieve the directional solidification. Now see, here comes the concept of a gate. We can see that there are three gates: gate 1, gate 2, gate 3. So based upon the position of gate in the mold cavity, we are actually distinguishing the types of gate. So now we are going to study the types of gate based upon their position. Till now, if you have any doubt, then please feel free to ask the questions. Sir, explain the HF equation with notation. Subham ji, okay. Subham ji has told HF equation. What is it? हाँ, see. ये जो है, I think जब आप फिक्स्ड प्लेट जब होता था ना, मतलब अगर कोई फ्लो कर रहा है लिक्विड फ्रॉम दिस फिक्स्ड प्लेट कंडीशंस, राइट? तो आपको पता है कि हेड क्या होता है, 32 म्यू. म्यू इज व्हाट? म्यू इज योर viscosity. U bar is the average velocity, right? Average velocity. Suppose this is a condition in which so in this is a pipe flow is there. So in this pipe flow, suppose this is the length, right? This is the length, and this is the diameter, right? This is the diameter. So in this type of condition, so the head which is generated here, it is given by 32 mu. Viscosity is there. U bar is the average velocity. U max plus U mean by 2. Okay, and L is the length. Rho G you know, and D is the diameter of these things. So if this is a condition, we can say that if head will be high when the velocity will be high. Clear? Till now, if you have any doubt, then please ask with me. Kuldeep ji, what do you want to say? कोई डाउट है तो पूछ लीजिए, नहीं तो मैं एक न्यू इंपॉर्टेंट टॉपिक स्टार्ट करने जा रहा हूँ. टाइप्स ऑफ गेट. गेट समझ में आया या नहीं आया? हैव यू अंडरस्टूड दिस थिंग और नॉट? द कॉन्सेप्ट ऑफ गेट, द पोजीशनिंग, हाउ दीज थिंग्स आर गोइंग ऑन, डायरेक्शन सॉलिडिफिकेशंस, these things are clear to you or not? Which thing? See here, अगर चलिए देखिए, मैं ये तो समझ गया कि सिर्फ एक ही गेट जो है एनफ नहीं होगा हमारे इस मोल्ड कैविटी को फिल करने के लिए। अगर हमारे पास मोल्ड कैविटी बहुत बड़ा साइज का आ जाए तो क्या हो, अगर सिर्फ एक ही गेट होगा तो क्या होगा, कुछ इस साइड में सॉलिडिफिकेशन हो जाएगी लेकिन इस साइड में सॉलिडिफिकेशन होगी ही नहीं, क्योंकि मोल्टन मेटल को तो टाइम लगेगा यहाँ से यहाँ फ्लो करने में। तो इस जगह पर मोल्टन मेटल जो है, जब तक इस जगह पर मोल्टन मेटल पूरा भर जाएगा उसके बाद ही इधर जाएगा। तो जितने देर में यहाँ तक जाएगा मोल्टन मेटल, तब तक में इस जगह पे क्या हो जाएगा, सॉलिडिफिकेशन हो जाएगा। मोल्टन मेटल वहां पर क्या हो जाएगा, सॉलिडिफाई हो जाएगा। तो प्रॉब्लम क्या हो गया सर, सॉलिडिफिकेशन जो है ना बहुत उल्टा सीधा हो गया। यहाँ पे मोल्टन मेटल सॉलिडिफाई कर गया, यहाँ पर नहीं किया, यहाँ पर नहीं किया। तो इस तरह के एब्रप्ट कंडीशंस में हमारा जो कास्टिंग होता है वो बहुत ही खराब क्वालिटी का निकलता है। तो इसको काउंटर हम कैसे करेंगे, हाउ वी कैन काउंटर, हाउ वी कैन improve these conditions? So we will do is that we will use a same sprue of only one sprue is there. The difference is that we will use the different gate, right? So this is the first gate, this is the second gate, and this is the third gate. So we will take like we can use any type of n number of gates based upon the situation and the design practices followed in the foundry by the foundry personals. Okay, so see, so suppose if I am using these three gates, okay, these three gates I am using. So suppose this is the second gate. So from second gate here, from the molten metal will flow. From third gate also molten metal will flow. So if this is the condition, molten metal, the flow of molten metal throughout the mold cavity would be there, and that too, that will be uniform in nature, right? So that too, it will be uniform in nature. Now see, if mold cavity, in this mold cavity, molten metal will flow uniformly, hence the solidification will happen uniformly, right? So there would be a uniform solidification for that, and hence a directional solidification is achieved. Now see, again there is a one problem. What is one problem is that if the time, see, you can say that this is the shortest distance, because from this sprue the molten metal will flow from here and again it will start filling. And see, this is the, this gate area, this gate length is very high, gate area is different, gate length is different. So based upon the size of the second gate, what I can say that it will take a lot of time, right? It will, and this will also take a lot of time. So there is, again there is a change in the flow rate. So flow rate, if flow rate is same and the area is different, so again there is a problem of direction solidification. अगर ये लेंथ यहाँ से टाइम ज्यादा लग रहा है, यहाँ से भी टाइम ज्यादा लग रहा है, तो क्या प्रॉब्लम हो रहा है, डायरेक्शन सॉलिडिफिकेशन नहीं हो सकता। तो अगर मैं कुछ ऐसा करूं कि इन तीनों में जो हमारा फ्लो रेट है वो अगर अनइक्वल हो जाए, किसी में ज्यादा हो जाए किसी में कम हो जाए, सपोज करें इसमें फ्लोरेट ज्यादा हो जाए इसमें फ्लोरेट कम हो जाए, तो मेरा प्रॉब्लम सॉल्व हो जाएगा, है ना, क्योंकि इसमें टाइम ज्यादा लग रहा है इसमें फ्लोरेट ज्यादा हो जाएगा। तो टाइम ज्यादा लग रहा है कोई बात नहीं, लेकिन एक बार में ही बहुत ज्यादा अमाउंट घुस जा रहा है ना। सो बेस्ड अपॉन दैट व्हाट आई कैन डू, इफ द रनर फीड्स मोर नंबर ऑफ गेट्स द रनर डाया इज रिड्यूस्ड, सो आई विल रिड्यूस दिस रनर डाया, आई कैन रिड्यूस दिस रनर डाया, एंड बाय रिडक्शन इन दिस रनर डाया I can get the unequal discharge in all the three gates, right? And when I will get the unequal discharge, hence my uniform direction solidification would be there, right? अब समझ में आया? Now you got the concept, Asis? Now see, now let us see a new topic. Let us see a new topic, that is types of gate. Clear? So I think this is clear to you. Now types of gate. Good, 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 good. Now see, now understand the types of gate. Now see, suppose this is first type of gate is known as top gate. Top gate. What is top gate? What is top gate? See here. Suppose this is my sprue. This is my sprue, and the sprue is feeding. This is runner, and with this runner there is a casting. So this is my mold cavity. Here this is my casting will form. So you can say that gate is on the top. Gate is on the top. Okay, and hence it is known as top gate. Clear? The second type is bottom gate. Bottom gate. What is bottom gate? See here. This is my sprue, right? And this is my runner. This runner will be fixed like this. So this is my casting. So here what you can see that this is the bottom, clear, and hence the gate is here, right? This is the gate. This is the gate. This is the gate. So this gate is actually here. So the since gate is at the bottom, hence it is known as bottom gate. Gate is at the top, hence it is known as top gate. Clear? So I think your this name is justifiable to you. You can relate these things. Now next is what? Next type of gate is parting line gate. Parting. What is parting line gate? What is parting line gate? If you will see the figure, let me draw this figure. So you have the sprue, clear, and this sprue is with a runner. There is a runner, and this there is a mold cavity like this. So you can say that partly it is, suppose this is h1 and this is h. So partly there is a two heights, right? So we can say parting line gate means what? So see, we can analyze this situation. We can analyze this situation as this. So this is a case of a bottom gate, and this is a case of a top gate. So parting line gate is a condition in which a situation can be analyzed at two cases. So case 1 is there and case 2 is there. So it can be analyzed with the case of a bottom gate and top gate. बीचों बीच होता है, ठीक है? समझ में आ रहा है? समझ में आ रहा है कि नहीं आ रहा है चीज? Everything is clear to you or not? Tell me. Fourth is step gate. स्टेप गेट में क्या होता है? बहुत सारा हो जाता है, ठीक है? स्टेप गेट हम समझेंगे बाद में, ठीक है? स्टेप गेट थोड़ा सा कॉम्प्लिकेटेड है, थोड़ा टाइम लेते हैं एंड देन वी विल डिस्कस दीस थिंग्स. जस्ट अ मिनट. Okay, so now so everything is clear to you? Good. You all are understanding everything. So if you have any problem, then meanwhile you can ask your doubts, and I will take your doubts once I will finish the topic. Clear? My voice is breaking. Okay, my voice is breaking. It's just a minute. Now is it okay? Now is my voice okay? While you can give. Now my voice is okay. Okay. Subham has told sir it should be first top then bottom. Why bottom and top? Subham ji, see here. See this thing. See this thing. This is my casting, right? So suppose this is my casting. Just this is the thing. Okay. This is my casting. See, for a casting, this is my top. This is my top, and this is the bottom, right? For a casting, this is the top side, and this is the bottom side, right? So that's why, since gate is associated with the top side of a casting, hence it is known as top gate. Clear? Clear, Subham? I think it is clear. Okay, so now just see the next thing. Now let's analyze the top gate situation. Let's analyze the top gate situation. So, suppose this is the, so now see, this is my mold is there, right? Mold is there, green sand is there. This is sand, green sand is throughout the place, and this is the mold cavity, right? So this is the mold cavity. Now see, let us assume this to be a point 1, this to be a point 2, this to be a point 3. Clear? And let us assume this to be, this height to be HC. Clear? Height of the cup. So here the cup is there. Let this height to be a HS. Okay, so what is HC? HC is the height of cup. What is HS? Height of sprue, right? And this is the, let this height to be a total height, net height, that is HT. Net height, that is HT. So this is to be HT. So this is total height. Clear? Now let us assume this height to be, let us assume this height to be HM. Okay, so height of the mold. What is HM? Height of the mold. Clear? And so suppose what is AM? Let us suppose AM to be a uniform cross sectional area, uniform cross sectional area of casting. Clear? Uniform cross sectional area of the casting, right? And so this is what is the thing. And see here, this is my sprue, this is my sprue. Clear? This is my sprue, and this is my, this is the area associated with this sprue. This is the gate, right? And this is the runner. Now see, now see here, if I would say that Q, what is Q? Q is equal to AC into V max. Now before that I would just पार्टिंग लाइन गेट फिगर की बात कर रहे हैं शुभम. ओके सर, थर्ड नंबर आई एम आस्किंग पार्टिंग लाइन गेट. ओके, थर्ड नंबर. ओके 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 ओके. I understand. I understood. I understood. See, see here, that would be, see, that would be a case of a bottom gate. Why I have told you. See, if I will take here, if this is my, see, if this is my mold cavity, this is my mold cavity, I have taken a parting line. I have taken a parting line. Okay, I have taken a parting line and separated these two things. Right, I have separated. So just think about a condition that you took a parting line and separated these two things. So suppose I am having like this. First would be the, suppose this is 1, this is 1, and this is 2. So let this is to be 2. Now think, you are feeding this, you are feeding these 1 and 2 with this same sprue and runner. So see here what kind of condition is there. So there is a sprue, and with this sprue you are feeding like this. right? Think about this. And with the same sprue you are feeding like this. So see, you are feeding in the bottom part and you are feeding on the top part. Hence this is top gate and the bottom gate. Clear? Clear, Subham? This is clear or not? And see here, see here. So you can see this is a 1, 2 and 3. So what we can say, the area associated with the runner is known as AR, right? Runner area. Area associated with the gate is known as AG. Clear? AG. And area associated with the sprue is known as AS. Suppose area of runner is AR, area of gate is AG, and if we will see these three areas, then see here, there is a concept of choke area. There is a concept of choke area. First I will tell you the choke area, then I will explain these things. So there is a concept of choke area. What is the concept of choke area? That, take a new page. So there is a concept of choke area. Let me tell you the concept of choke area. So we have seen that AS is the sprue area, right? Next AR is the runner area. AR is the runner area. Next is AG is the gate area. Now see, so I can say that what is choke area? Choke area, let it defined by the AC. Let us define the choke area with the AC. So we can say that AC is going to be my choke area, and that is actually minimum of sprue area or runner area or gate area. So whichever the areas, that is the sprue area or the runner area or the gate area, among these three, whichever the value will be less, will be minimum, that will be my choke area, right? So definition of the choke area is what? जब भी हमारा कोई भी एरिया छोटा होगा सर, स्प्रू एरिया में, रनर एरिया में, गेट एरिया में, जिसमें भी कुछ कोई भी अगर छोटा होगा ना, वही हमारा सर चोक एरिया हो जाएगा. So suppose that if it is had been given that AR is to AG, right? If the ratio is given as, suppose that 2 is to 3 is to 1, right? 2 is to 3 is to 1, right? If you have been given the ratio of sprue area is to runner area is to gate area is 2 is to 3 is to 1, and in this suppose that you have been given that sprue area is 500 mm², right? So suppose if it is 500 mm², so what I can say that this is 500, right? Now it is 3, so 3 by 2, if I will do the 3 by 2 of 500, then I will get the ratio. This ratio is going to be 750 mm², right? And if it is 1, then 1 would be, right, 2 parts is 500, 1 parts would be 250. So from here what we can say that if this ratio is given that sprue area is to runner area is to gate area is 2 is to 3 is to 1, and if this sprue area is given, so based upon that what I can say that this area is my minimum, right? So this area is my minimum, and since this area is my minimum, hence I can say that choke area is going to be is equal to 250 mm², because it is minimum. So this is the concept of choke area. So I think the concept of choke area is clear to you, and if the concept of choke area is clear to you, so let us come back to our discussion. So for here what I can say that discharge, that is the Q is equal to AC into Vmax. Why I am taking the choke area? Because why I am taking this AC is actually choke area, right? See, जो भी एरिया छोटा होगा ना, वो हम एरिया ले लेते हैं इनटू मैक्सिमम वेलोसिटी ले लेते हैं, तो हमारा डिस्चार्ज जो होता है, दिस इज द कंडीशन टू फाइंड द थिंग्स, राइट? तीनों में से जो छोटा एरिया होता है वो एरिया को हम ले लेते हैं. नाउ सी व्हाट इज द मैक्सिमम वेलोसिटी इन दिस केस, व्हाट इज द मैक्सिमम वेलोसिटी इन दिस केस, right? See, so this is the, in this way the molten metal is flowing, right? Now see, it can be equal to, it can be equal to, see, this is the area of mold, right? Am, area of mold. So I can write that this can be is equal to area of mold. And see, the most important thing is there, when you are pouring the molten metal, when you are pouring the molten metal, so see, at time, so at time t, suppose at time t equal to t equal to some time t, then this is pouring some high dh, right? So some high dh will be poured after some like sometime t1 plus something delta any other time, then it will change its heights. So we can see there is a variation in height is there. So एक ही बार में भर नहीं जा रहा है, एक हाइट का वेरिएशन हो रहा है इसमें. तो what I can say that, what I can say that is am into dh by dt, right? So dh by dt मतलब क्या, एलिमेंटल पार्ट ले लिए हैं और इस तरह से हमारा वेरी कर रहा है यहाँ पर, मोल्टन मेटल जो फिल कर रहे हैं उस तरह से फिल हो रहा है यहाँ पर. सो नाउ रीअरेंजिंग दीज थिंग्स, व्हाट आई कैन से दैट AC इज देयर, AM इज देयर, सो आई कैन से AC by AM, AC by AM, and this is the Vmax. Vmax, what is the max? Vmax, what I can say that this is the Vmax, this is the Vmax. Clear? Height is what? Head is ht, maximum head is ht. So maximum head corresponding, so we can say that velocity corresponding to maximum head is my Vmax. Clear? So this is the Vmax. So what I can say that AC into AM into Vmax, this is, let dt be this side, dt is equal to dh, right? Now see, I can say that if time t is equal to 0, if time t is equal to 0, it has filled, suppose this is at here, so at time t is equal to 0, height is equal to 0, right? And at time t is equal to some time t is equal to t, so it has filled, height h is equal to hm. So what I can say that is t is equal to 0, so height is also 0, and at height is equal to hm, it will filled when t is equal to some time t. Now just we have to integrate these things. So what I can get that AC into, see here, this is AC by AM into Vmax into T is equal to DH, right? So this DH can be written as HM. Clear? Now rearranging these things, so HM is equal to AC into Vmax into T by AM is there. Now see, from here this is the T. What is this T? This is the time required to pour the molten metal, right? This is the T, that is time required to pour the molten metal. So from here I will get the T is equal to AM into HM by AC into Vmax. Clear? Into Vmax. So this is the time. What is the time? What is that this time? What is this time? This time is actually nothing but pouring time. This time is nothing but actually pouring time, है ना? Pouring time, कितना time लग रहा है molten metal को pour करने में, that is called as pouring time. So T is equal to AM into HM by AC into Vmax. This thing is clear to you. Now see here, dear friends, see here, what is this AM into HM? What is this AM into HM? See, this is the AM, that is the area of the mold cavity, and this is the HM, that is the area of height of the mold. So AM into HM is what? AM into HM is the volume of mold, right? So we can say that this is the volume of mold. So my equation will be like this: T is equal to AM. So we can write, we can replace this by VM, which is VM is the volume of mold, right? Let me write it. VM is the volume of mold, right? So Vm into AC into Vmax. Clear? This is the volume, right? And this is the velocity. Clear? So there should not be confusion with that. And this is the equation that we have got. This is the equation that we have got of the pouring time. This is the pouring time calculation here, right? Now see, So this is the pouring time. So let me write T is equal to, right, Vm, volume of mold, AC into V max. Now see here, what is the unit? Unit is mm cube, right? Mm cube is the unit. And see, what is its unit? Its unit is mm square. And what is its unit? Its unit is mm per second. What is its unit? Its unit is mm per second. So what I can write as mm square into mm per second. So by unit we can say that these things will be cancelled out, and hence we will get second, right? This cube, this square will get cancelled, and hence we will get the unit as second. So this is the formula. This is the formula of pouring time. Pouring time in case of a top gate, right? So if in question in gate there are a lot of question that is has been asked from this pouring time from the top gate, so you just have to remember the, if this is a top gate condition, if this is a top gate condition, and then in that condition my pouring time will be this Vm is a Vm by AC into Vmax. This is clear or not? This formula is clear or not? Tell me. So I think this is clear to you. And see here, so see, velocity in the top gate is maximum, right? So it is desired. Now let us see about the bottom gate. This is clear to you? Tell me, just give me a thumbs up so that I can understand. Okay. कोई डाउट? यहाँ तक कोई डाउट नहीं है आप लोगों को? नो डाउट? आप लोग तो बहुत तेज हैं, बहुत तेज हैं आप लोग तो. Very brilliant minds are there. चलिए बढ़िया, good. Now let us see the another condition, that is a bottom gate. Bottom gate. Now see, what is the bottom gate? Suppose this is again what I'm drawing. So this is my sprue, and this is runner, and this runner is feeding a mold cavity is there, and suppose this is like this. Okay, this is my casting or mold cavity. So this side green sand is there, clear? This green sand is there throughout, and this is my mold cavity, right? So this is my casting. Here my casting will be there, right? Now see, now see, now see here. So this is the first point 1, point 2, point 3. Here again same notations are there. What are the notations, sir? What are the notation is there? This notation is HC. This notation is, this is the height of the sprue. This is the sprue, so height of the sprue, and this is the total height. This is the total height. Clear? Now see, again molten metal will flow through it, right? Molten metal will flow through it, and what I can say that molten metal will flow, right? So now suppose that if I am taking the height h, suppose if I am taking a height h, and at height h, if I will analyze these things, then again I will be able to find that it is varying throughout the height, right? It is varying throughout the height. So in this case, what we can say that, suppose, so we can say that head is variable, right? Here head is variable, because see, at some time, at time t is equal to something, it will fill some height, and again at time t is equal to t, again it will fill this height. So suppose this height of the mold, suppose this is the height of the mold, and height of the mold to be hm. Clear? So see these things, these notations we have seen. What is these notations? That is the hm is the height of the mold. Clear? Hm is the height of the mold, vm is the volume of the mold. Now what we are going to see, since head is variable, since head is variable, that we can see head is variable. So suppose this is the what we can say that, if I will apply the Bernoulli's equations, suppose 0 plus 0 plus ht would be there, right? If this is, if this is my datum, suppose this is my datum, then I can write the gauge pressure is going to be 0. Okay, not right, I should not write like this, because you will not, again you will have some problem. Let me write like this. So p atmospheric by rho g plus here, so at 1 and 3, right? At 1 and 3, so what we can say that if datum is this like that, then the velocity would be at point 3, this is going to be is equal to 0, plus height is going to be ht. And see, so see here, so from the bottom this height is h, this height is h, so there the atmospheric pressure would be there, p at patm plus rho g, plus c here, this would be having v square by 2g. Velocities at this section is going to be v square by 2g, right? Because there would be some velocities. Through this velocity, this entire mold cavity would be filled, right? With some velocity, this entire mold cavity would be filled. So patm plus v square by 2g plus of h. So suppose this is some height h, and if this is the condition, so what we can say that these things will be going to be 0 neglected. So see, v is equal to root over 2g ht minus of h. Clear? So this is the velocity, that what we are getting. Now see, to find the pouring time at this condition, what should be our assumptions? So suppose that if I am taking a small uh, elemental part, and analyzing the situation at this part, so what would be the dq would be again ac into v max, right? See, again see, earlier what we have seen, q is equal to ac into v max. Now see here, dq is equal to ac into v, which is nothing but ac, and v is, just now we have find as 2g ht minus of h. Clear? So this is the dq, now see, we know that dq is what, dq can be written as am into dh by dt. See, just the same thing that what we have written till now, right? Am is equal to dh by dt, so am into dh by dt. So what I can write, I can equate am into dh by dt is equal to ac into root under 2g into ht minus of h. Now see, I'm just writing these things here, so see here, I'm just writing here am into dh by dt is equal to root under 2g into ac into root over ht minus of h. Why I am writing separately, you will just understand, in the next step. Now when I will do this, i can write as i can write as I can write as like this, 1 by root over of ht minus of h dh 0 to hm is the height, right? Hm is the height, so we will reach the height hm. Clear? We will release the height hm. AC by am into root over of 2g into root over of 2g into dt. So integrating this dt from 0 to t. Now till now if you have any doubt, then I just check it because I have done a lot of steps. तो यहाँ तक अगर कोई दिक्कत हो तो मैं देख लेता हूँ आप लोगों का एक बार कमेंट. Okay, fine. So there is no comment from your side. So this is till now what we have seen the steps, right? Now see what is the thing is that what we can say here. What we can say here is this 0 to hm. Clear? 0 to hm. So now just our duty is to integrate this, right? Our duty is to integrate it. So how we can integrate it? What is the integration formula? So see here, I don't know you guys remember or not. See here, if I will be having as dh by root h is there, right? See, dh by root h kind of conditions are there. So if this is the condition, so I can write integral is there, that h to the power minus of 1 by 2 dh. So if I'm integrating these things, I will be getting as h to the power minus 1 by 2 plus 1 as minus 2 1 by 2 plus 1, right? And hence I will get as root h by 1 by 2, and this would be right. This would be like 2 root h. So integration of dh by root h is 2 root h. Clear? Now I will just integrate these things, right? I will just integrate these things. So let me write these things here, that I'm getting as uh, dh by root over of ht minus of h. This is h is equal to 0 to h is equal to hm. Clear? This is equal to ac by am into root 2g dt. T is equal to 0, t is equal to t. Just these things we have derived, right? So now if I will integrate this, I will get as negative 2 root over of ht minus of h, right? And there would be 0 to hm. This would be ac by am into root 2g, and this would be 0 to t is there, so this would be t. Clear? So now I can find that if I will rearrange this t, then I will get that t is equal to 2 am by ac into root 2g root over of ht minus of root over of ht minus of hm. Okay, so this kind of equations we will be getting like this. So this is the pouring time for bottom gate Clear? Sir, please explain first line. Which first line? This first line. Integration is there, simple integration is there. So see here, so this is the pouring time that we are getting. This is the pouring time we are getting. Now this is the pouring time for a bottom gate. Now see, most important thing, there is some special case, right? See what is hm. See this equation first of all, and then I will explain some of the key points here. See what is hm. Hm is the height of mold, right? See here, this is the height of the mold, right? This is the height of the mold. Now see, if what if what if I will take a situation like this, right? Suppose अगर मेरा height of mold क्या हो जाए, कुछ ऐसा हो जाए है, अगर मेरा height of mold कुछ ऐसा हो जाए, if my height of mold will be this, then I can say that this would be my height of mold, and see, this is nothing This is nothing but this is my height of the mold, and as a matter of fact, height of the mold is of the same height that is of the HT. So what I can say that this is the thing, HM is equal to HT. Yes, Vmax can be written as root over of 2gh. Yes. Which equations you see? This equation, Q is equal to AC into Vmax. The same equation is there here also. First equation, oh, in this case head. So see, if you will see, this is the height HT, right? If you are taking this height, this to be as datum, considering this to be a datum, right? This to be a datum. So what you are doing, you are analyzing the flow, velocity at this part. So suppose you took the elemental part here, and this height is h, clear, because it is varying throughout the height. So what I can say here, that at this point, it is having the atmospheric pressure. So I know that, throughout atmospheric should be there, so that अगर atmospheric नहीं होगा ना, think about that, if at these two points there would be a variation in the pressure, then there would be a pressure gradient. And if there would be a change in pressure, if there is a pressure gradient, then pressure gradient simply means that we will invite the air to come inside the sprue and to the casting. So hence, throughout the casting, it is assumed that my pressure is atmospheric pressure throughout the analysis, right? So this is my P ATM by rho g plus g. Velocity at this point is going to be 0, plus height is ht is equal to P atmospheric by rho g plus of v square by 2. Suppose the velocity is v square by 2g, and height is what? H is the height, and hence we are getting this simple Bernoulli's equation is there. Right? Bernoulli's equation is there. So now see, yes, in the Jit we can write Vmax to be written as a root over 2gh. See here, what is Vmax? Vmax would be actually root over 2g h3, right? Because h3 in place of h3, let me write ht, because this is the maximum head, and the maximum head के corresponding ही तो हमारा maximum velocity होगा, है ना? Now see, what is the case that I have told you? Suppose that if let us see a special case. So what is the special case? What is the special case? What is the special case? Suppose if this was my height of the mold. Now if my mold height is like this, if this all everything is my mold height, then you can see my mold height is actually is equal to ht, right? These two heights, it is the ht and this hm, right? Because now my mold cavity is this, so if this is a condition, then I will get like this. So if this is a condition, what is the thing that we have seen? That for a special case, ht, that is height ht is equal to hm, right? Height of the mold is actually is equal to ht is equal to hm. So we can say that my first pouring time calculations we have seen. So my pouring time will be reduced to as 2 am by ac into root over of 2g, right? Root over of 2g into this, that is root of, clear? This is what we will get, because this is going to be 0, now see, can I write as 2 am by ac, clear? 2 am by ac into root over of 2g into, this is the root ht, right? Root ht is there, so I can write as root ht into, let us assume this to be as HM by HM. What I have done, I have multiplied and divided by height HM. Just for instance, I have multiplied and divided by the height HM. So I can do it. Now see, from this equation we can see that for this special case, HT height is equal to HM. HT is equal to HM. So now in place of HM, in place of here HM, what I can write? I can write HT, because HT and HM both are same, right? So now if that is the condition, then my equation will be reduced as this is twice, this is AM, this root over HT by HT is there, so below would be root HT, so AM HM, and here this would be AC root over of 2G HT, because there is a, here see, here what will happen, here this HT and this ST, so there would be root HT, and hence this root HT is here, right? This hence root HT is here. So what we are getting here, this is what, this AM into HM is what, this is nothing but volume of mold. This is nothing but volume of mold, and I have denoted this volume of mold as VM, right? I have denoted this volume of mold as VM. So what I can write here, I can write here to be as 2 VM by AC into root over of 2G HT, right? 2G HT. See here, 2G HT. What is 2G HT? What is 2G HT? See, what is 2G HT? Root over 2G HT is nothing but V max. That is the maximum velocity. Maximum velocity. So what I can write here is nothing but, see, 2Vm by AC into V max. Clear? This is the thing. Now see this equation. See this equation. And see this equation. So in this case, in case of a top gate, I got the pouring time as is equal to Vm by AC into Vmax, and in case of a bottom gate, I am getting twice of Vm by AC into Vmax. So can we tell that that is time required at bottom gate is equal to two times time required, or better to say twice time required at top gate. Clear? So this is the main important conclusion that we have got. Time required at bottom gate is equal to twice time required at the top gate. Clear? So this thing is clear to you or not? This thing is clear to you or not? Till now, do you have any confusion? कोई दिक्कत है आपको तो पूछ लीजिए मुझसे. आई एम वेटिंग फॉर योर queries. I'm waiting for your queries. Okay. Okay. So you don't have any doubt, then it's fine. Completely fine. Now see, next is parting line gate. So I have already told you how to deal with the case of a parting line gate. How to deal with the case of a parting line gate. Parting line gate. So for a parting line gate, suppose this is the condition, this is the pouring cup, this is my sprue, and with this sprue there is a runner connected, and with this runner I'm having the mold cavity here. So this is the thing. So what I have told you, that flow of the molten metal will be like this. Clear? So now if suppose if this is height, this height is my hm1, height of the mold at first section, and let this to be height of the mold at second section. Clear? So you have to analyze these things, so, by taking the case of the top and the bottom gate. So what you will do, suppose this is the case of a this is the case of a bottom gate, so this is the case of a bottom gate, right? So you, what you will do, you will just apply the formula. What is the formula? Suppose this is a t1, so t1 would be am by hm2 by ac into root over of 2gh. Clear? And again you will use another formula, pouring time is equal to twice am by ac into root 2g root of ht minus of root of ht minus of h. And by using these two formula you can solve the problem of parting line gate. Clear? You can solve the problem of parting line gate. Now next thing that I have told you, next thing that I have told you is the step gate, is the step gate, is the next case is for the step gate. Next case is for the step gate. Now see what is the case of a step gate. Suppose that this is a sprue. This is the sprue, right? With this sprue, what you are doing, what you are doing. So from here, suppose this is a mold cavity is there here. So you are dividing in some sections. Okay, so some sections are there. Some sections are there. Some sections are there. In with sections, with these sections, what you are doing, what you are doing, right? So suppose this is a sprue. So from sprue molten metal will flow like this, right? Flow like this, flow like, right? Flow like. Clear? So what you are doing, what you are doing, so to fill the molten metal or molten liquid metal into very large, I've already told you, because these things are used for very large size mold, right? Because we need very we have very less time, and in this less time we are going to fill it, right? And we are also not in a hurry, like जल्दी जल्दी में भर के फिर कास्टिंग का डिफेक्ट हो जाएगा, फिर खराब हो जाएगा, फिर कोई मतलब नहीं है। जल्दी जल्दी भी नहीं भरना है, एक एक ऑप्टिमल टाइम में भरना है, ठीक है ना? जल्दी करना है ना ज्यादा लेट करना है, ठीक है? सो टू फिल द molten liquid metal into the very large size mold, right? Very large size mold cavities, number of gates, number of gates are provided vertically in the form of steps, right? So there are a lot of steps in the form of step 1, step 2, step 3, step 4. So a lot of steps are there, and in these steps you are providing the gates, right? So with this form of so this is the vertically in the form of steps, and hence these are in such a way that liquid metal, right, liquid metal can be filled into the cavity, mold cavity, right, into the cavity within a given, within a given, within a given time without causing turbulence. Okay, turbulence and splashing, these are the two problems are there. So समझ में आया आपको स्टेप गेट? हम्म, स्टेप गेट समझ में आ गया होगा आपको अभी तक, ठीक है। तो जो चीज, एक और जो चीज है कि यहाँ पर जो मैंने आपको बताया था चोक एरिया का कॉन्सेप्ट, चोक एरिया कॉन्सेप्ट बताया ना, कि चोक एरिया कॉन्सेप्ट क्या होता है, स्प्रू एरिया होता है, रनर एरिया होता है, गेट एरिया होता है। तो यहीं पर एक कॉन्सेप्ट मैं बता देता हूँ आपको, गेटिंग रेशियो का। दैट इज अ कॉन्सेप्ट ऑफ getting ratio. What is happen in this getting ratio? So getting a ratio is the area of the ratio, and the area of the ratio is sprue area is to runner area is to gate area, to gate area. This ratio of this area is actually known as getting ratio. So this is the thing, right? So this is the getting ratio. Fine, this is the getting ratio. So just remember, sometimes in gate it has been asked that tell me कि बीच में कौन सा होता है, बीच में रनर एरिया होता है या गेट एरिया होता है या स्क्रू एरिया होता है। तो ये सारी चीजों को आपको याद रखना है, ठीक है, ताकि हम गेट में आंसर कर पाए। दो स्टेप्स गेट इंक्रीज द चांस ऑफ गैस डिफेक्ट्स इंक्लूजन्स। सी See, in this case, we try our level very hard. We apply the strainer, we give the skim bob, everything is there. But see, since there are a lot of steps are there, so yes, in these conditions, lot of steps are there. It simply means that we have a lot of, we have to pour a lot of molten metals, right? To to filter these all molten metal, it is very tough. But थोड़ा तो impurities रह ही जाता है, it can be. So these things are there, right? These things are there. Till now I don't think you will be facing any problem. कोई दिक्कत तो होगा नहीं, दिक्कत है तो बता दे मुझे। चलिए इस क्वेश्चन को थोड़ा देखते हैं। कैन यू टेल मी दिस क्वेश्चन, कैन यू आस्क दिस क्वेश्चन, गिव मी द आंसर ऑफ दिस क्वेश्चन। बता सकते हैं मुझे इसका आंसर? टेल मी द आंसर। A. So just now we have seen these things, जस्ट नाउ वी हैव सीन दीज थिंग्स। सर रोड रोलर कौन सी कास्टिंग से बनती है? सर रोड रोलर जो है ना, हम शुभम जी, हम अभी पहले तो कुछ न्यूमेरिकल वाली चीज को हम कवर कर लेते हैं, ठीक है। फर्स्ट माय एम इज टू कवर द न्यूमेरिकल पार्ट। सो न्यूमेरिकल पार्ट में ये आपका गेटिंग रेशियो का चीज आ जाता है, ठीक है। टॉप गेट बॉटम गेट पे बहुत क्वेश्चंस आता है बोरिंग टाइम पे। फिर अपने लोग, हम लोग राइजर डिजाइन देख लेंगे, पहले गेट डिजाइन हो जाता है, फिर राइजर कैसे डिजाइन करते हैं। फिर उन सारे न्यूमेरिकल चीज को देख लेने के बाद फिर मैं सोच रहा हूँ कि लास्ट में मैं आपको कुछ स्पेशल कास्टिंग्स बताऊंगा। तो उस कास्टिंग को जब मैं डिटेल्स में बताऊंगा, जैसे ग्रेविटी कास्टिंग, pressure die casting, investment casting, right? Shell molding casting, slush casting, a lot of casting are there. तो वो थ्योरी पार्ट में बाद में करना चाहता हूँ, और उसमें मैं आपको बताऊंगा कि रोड रोलर जो है किससे बनती है। बट फॉर टाइम बिंग आप ये भी समझ सकते हो, अगर आप पढ़े हो तो आपको पता होगा कि रोड रोलर कैसे बन सकता है। रोड रोलर इज लाइक दिस, एंड इट इज एक्चुअली एक्सियल सिमेट्री, इट इज इन एक्सियल सिमेट्रिकल, राइट? सो अगर मैं इसको सेंट्रीफ्यूगल कास्टिंग से यूज करूं, सेंट्रीफ्यूगल कास्टिंग से यूज करूं, तो ये हो जाएगा, ठीक है। तो दीज थिंग्स दैट वी हैव सीन, लेकिन इसमें हम और डिटेल्स पे जाएंगे। सेंट्रीफ्यूगल कास्टिंग ही इनफ नहीं है, कुछ और से भी हम बना सकते हैं। नाउ सी, सो स्क्रू एरिया, टोटल रन एरिया, टोटल गेट एरिया, दीज थिंग्स आर क्लियर टू यू, राइट? सो ऐसे क्वेश्चन पूछा जाता है, है, ठीक है, गेट में ऐसा क्वेश्चन पूछा जाता है। चलिए इस क्वेश्चन को देखिए, ये क्वेश्चन है, ट्राई टू गिव मी द आंसर, ट्राई टू गिव मी द आंसर। टेल मी द आंसर। A D A, okay. Minimize the temperature quick. Getting system is proved. D, okay. Quick fill the mold cavity. See, स्प्रू का तो काम ही होता है कि फीड करे वो, है ना। लेकिन लेकिन इन दिस क्वेश्चन, always and always sir and madam, you have to see and study the question very cautiously. See, the if I will say that what is the use of a sprue, definitely the use of a sprue is to fill the mold cavity, right? मोल्ड कैविटी तो स्प्रू से ही जाता है ना, तो वो तो फीड करने के लिए काम आता ही है, दैट इज द मेन थिंग। बट हियर इट हैज बीन टोल्ड दैट it is usually tapered. Why it is tapered? Why it is tapered? We have seen that if this is this, these things are there, but when we pour the molten metal, when we pour the molten metal will pour in a parabolic curve. But even if it is in the parabolic curve, so to achieve this parabolic curve, to achieve this parabolic curve, hence this sprue are made taper. And why it is made taper? To avoid the air aspiration effect. Clear? To avoid the air aspiration effect. चीजों को ध्यान से देखिए, यहां पर आपसे टैपर्ड पूछ रहा है, राइट। टैपर्ड दे दिए, टैपर क्यों करते हैं, स्प्रू क्यों यूज करते हैं, दैट इज ओके। स्प्रू अगर मैं क्यों यूज करूंगा ये चारों होगा, लेकिन स्प्रू को मैं टैपर क्यों कर रहा हूं, टैपर तो मैं सिर्फ एक ही कारण से कर रहा हूं, ताकि एस्पिरेशन इफेक्ट ना हो। क्लियर? क्लियर? ये सब बहुत अच्छे अच्छे क्वेश्चंस हैं, ये आपको बहुत कंफ्यूजन में डाल देगा, लेकिन आप सॉल्व तो कर दोगे, आप सोचोगे कि आई हैव done correct, but as a matter of fact, when you will understand, then you will find that okay, I have done the mistake. Fine. Now see, I'm just giving a one question. Find the pouring time. This is the question I have given to you. Find the pouring time. Is this question visible to you? दिख रहा है ना, छोटा तो नहीं पड़ गया? नहीं दिख रहा है, चलिए try to solve this question. Now try to solve this question and tell me the answer. See, in this question, this is the volume. Okay, I'm giving you just a minute, because that would be गलत हो जाएगा ना, मैं आपको 2 मिनट तो दूंगा ही, ताकि आप ट्राई करें एटलीस्ट। अच्छा, मैं और पढ़ा सकता हूँ आज के दिन, या फिर आई शुड फिनिश इट टिल नाउ? शुड आई प्रोसीड, और छोड़ दूं? आज ही छोड़ दूं इतना पर पढ़ा करके? टेल मी। और इस क्वेश्चन को थोड़ा ट्राई करें, मुझे आंसर बताएं। टेल मी द आंसर्स। Yeah, okay, I will solve this question, then I'm solving this question, and after solving this question, I'm ending the session. Okay. See. In a gating design, dimension of cavity is given 50, 25, 10 is there, right? So suppose if this is my 50, this is my 25, and this is my 10. Clear? Now see, it will be filled by providing a gate on the top and bottom of the cavity with the pouring height of 15 centimeter. So see, there is a pouring height. Suppose there is a pouring cup is there. With this pouring cup, there is a sprue, right? A sprue is there, and this sprue is here, is connected with like this, clear? So see, this height this height is given as 15, right? This height is given as 15, clear? So what I can say that I know that for a top gate, if it would have been a top gate, then pouring time is Vm, that is the volume of the mold, by Ag into Vmax, right? Vmax. And see, what is the volume of the mold? What is the volume of the mold? Volume of the mold is going to be is equal to 50 into 25 into 10, right? 50 into 25 into 10, clear? Now divided by what is Ag? What is Ag? See, here it is given as area of gate area is given as 5 centimeter square. So put 5 centimeter square, this is going to be centimeter cube, 5 centimeter square. And what is V max? 2g, right? This is what? 2gh, root over 2gh. So 2 into 9.81 into 50, clear? And if you will solve it, you will get as 14.57 seconds, clear? And similarly, for a bottom gate, if you will see, you will calculate for the bottom gate, time would be twice of am by ag into 1 by root 2g into ht, root over of ht minus of root over of ht minus of hm, clear? And when you will put the figures here, see what is the area. See again, what is the area? This is area is going to be is equal to 50 into 25, right? This is the area, 50 into 25. So here that is going to be is equal to twice 50 into 25. What is my gate area? Gate area is given as 5, 1 by root over of 2 into 9.81 into root over ht. What is root over ht? See here, see in this case, ht is 15. ht is 15. So this is going to be is equal to 15 minus of root over of 15 minus height of the mold, right? Height of the mold. What is the height of the mold? See, height of the mold is given as this. This is the height of the mold, right? This is the height of the mold, that is 10. So here this is going to be 10, and when you will calculate, you will get as 18.47 seconds. So thank you so much. Can we use Chronovis tool? Why will you use? अगर यहाँ पर सर आपको एरिया ऑफ गेट दिया हुआ है, गेटिंग सिस्टम्स का आपका सारा डायमेंशंस दिया है, एंड हाउ यू विल यूज, टोटल सॉलिडिफिकेशन टाइम होता है सर वो। आप अगर क्रोनोविस रूल से आप देखें तो दैट इज टोटल सॉलिडिफिकेशन टाइम, दैट इज नॉट पोरिंग टाइम। There is a difference between total solidification time and there is a difference between pouring time. Pouring time means what? How much time is required to pour the molten metal, and this total solidification time is like what? If this is my casting, then how much time this casting, this shape will require to solidify? That is known as total solidification time. So Nishant, don't confuse with these two terminologies. I will suggest you to think about these two terminologies, what is exact meaning of them, and then you will be able to understand the things. Okay, so for today's class, if you have any doubt, then please ask with me, and you can always use my code SIRVK if you are planning for the plus subscription. My code is SIRVK, SIRVK. So like my video, if you find my video to be very helpful for your GATE and ESE preparation, then do like my video, share this video with your friends and peers so that they can also prepare with you for the GATE and the ESE examinations. Thank you so much for your active participations, and if you have any doubt, then I'm open for your doubt. I'm giving you 2 minutes, 2 to 3 minutes time. I'm not ending the session, and you can ask the doubt with me in this 2 to 3 minutes time. After that, I'll end the session. Okay, yes. Tomorrow at 2 p.m. Tomorrow at 2 p.m. I will teach you vapor power cycle, and this is going to be part 2. Okay, tomorrow at 2 p.m. vapor power cycle part 2 will be there. Clear? And in the morning 9 a.m. strength of material would be there. Okay, and strength of material, what we are doing shear force and bending moment diagram. Clear? And 8:45 we will be seeing manufacturing. Okay, these are the timings. So no doubt is there with you? और कोई डाउट है तो फिर पूछ ले मुझसे. और अगर आप प्लस सब्सक्रिप्शन लेना चाहते हैं तो आप मेरे कोड को यूज कर सकते हैं SIRVK, SIRVK, and you can follow me on the Unacademy learning app so that whenever I publish is a new course or a new lesson, you will be notified as soon as possible. Okay, so thank you so much. I'm just ending the session.